derivatives of inverse functions. That will lead us to being able to do derivatives of logarithms and derivatives of sine inverse, cosine inverse, tangent inverse. But it turns out those we can just memorize. So even though I'm going to show you where they come from and how they work, they're going to be things we just memorize. Big thing with inverse functions will be some table problems that you'll see. And those get a little, they're easy, but if you don't know the method, they can be very difficult on the AP exam. So that's what we're going to look at today is derivatives of inverse functions. So what's the derivative of f of x? Find f inverse. And you have a note card on that probably, but switch x and y, solve for y. Y'all remember doing that in algebra 2. So x equals 2y minus 3. So x plus 3 divided by 2 is f inverse. Add the 3 divided by 2. Is that what everyone got? What is the derivative of that? Well, if I do a little bit of a rewrite on that, isn't that just 1/2 x plus 3/2? So what's the derivative? So the derivative of f inverse is 1/2. Compare the two derivatives. What do you notice about them? The derivative of the inverse is just the reciprocal. You agree? So it says graph f of x, f inverse. So f of x is, what was it, 2x minus 3. And we have and the line y equals x. What do you notice? Which you learned this in algebra 2. Those are symmetrical about the line y equals x. They are reflections over the line y equals x. X and y are switched, right? Would you agree that we should be able to tell something about the slope of the inverse based on the slope of the original? The only problem is, now this one's easy because the slope doesn't change anywhere on this graph, right? If I want to compare this point right here, the point 0, 3/2, and the slope at the point 0, 3/2, what is the equivalent point on the inverse? 3/2, 0, right? That's what you said, right? Why is it 3/2, 0? You switch the x and y. So if I want to know something about this slope, it's the reciprocal of the slope at that point. Would you agree? Because it seems that they are reciprocal. So that's what we're learning today. We'll do that tomorrow. So, derivatives of inverse functions. This is the proof. So it's not something you'll have to repeat, but it's good to know. If f of x and g of x, they are truly inverses, then wouldn't you agree that f of g of x is just x? They undo each other. That's what inverses do. So I'm going to implicitly differentiate f of g of x. What is the derivative of f of g of x? Good, which is just 1. So if I know the derivative of f, and I want to know the derivative of its inverse g, then g prime of x would be 1 over f prime of g of x. This is a formula that you should probably, it's a snap looking star. It's a formula that you should probably memorize. The derivative of the inverse is 1 over the inverse function of g of x. Now, someone remind me, what does g of x represent? The inverse. And if I'm talking about f of x or g of x, either way, I'm talking about a y value, right? So this is 1 over the derivative of the inverse at the y value of g. Interesting thought. So that's what we're going to be looking at today, how to make that work with numbers. Key things to remember. To find f inverse, you switch x and y and solve for y. I hope you already know that. The slopes of f of x and if f inverse are reciprocals. And don't forget that every x and y is switched. So if I want to know the derivative of a point on the inverse function, I have to look at its corresponding point on the original function, which would require a switch in x and y. This is something that can be a very difficult concept. But it turns out there's a quick table to make it really easy. I don't make you do note cards anymore. It's up to you. But this type of table for derivatives of inverse functions might be something to put on a note card to remind yourself how to do derivatives of inverse functions. If you like the note cards and you use those note cards, this might be a note card worthy event because it's not something you'll find on your calculus helper. I didn't make you make note cards for the derivative rules because you have a calculus helper, but this is something that's not on the calculus helper. So this table, I had never seen this, and I saw this at an AP conference. When I was in high school, I had to really think about which one was X and Y, and switching that information, and it was to me, this was a very difficult topic when I learned it. And then I went to an AP conference and saw this table and went, oh, that would have been helpful. You know, like things that would have been nice to know sooner. So this is an AP style question on derivatives of inverse functions. I know that derivatives of inverse functions are reciprocals. It says if f of 2 is 7 and f prime of 2 is 8, then what is f inverse of 7 and what is the derivative of f inverse of 7? It's really helpful to remind yourself what is x and y here. So it tells me that f of 2 is 7. So on the function f, at the x value of 2, the y value is 7. So I'm going to put that in my table. It gives me that information. It also tells me the slope at 2 is 8. It says that f prime of 2 is 8. So I know all of that about f of x. If I am going to use any information about that point for f inverse, what is the x and y on f inverse? Right? Isn't this, I know something about f inverse of 7. I know that y value is 2. And I know that slope is 1/8. Table is very, very helpful. Yeah, just the reciprocal. So f inverse of 7 is the first question. What is f inverse of 7? 2. Right? The y value on f inverse of 7. And what is f, the derivative of f inverse of 7? 1/8. me show you how I had to do this when I was in school and how the formula works. The derivative of f inverse is 1 over the derivative of f at f inverse of x. Okay, that's what the formula would say. What does that mean? Well, if I'm finding f inverse of 7, f inverse of 7 is 2, right? So this would be 1 over f prime of 2, which is 1/8. So if you prefer the formula, that's how the formula works. I kind of like the table. Like I said, I didn't learn the table in high school. I had to do it this way, and very rarely do you go away from the first way you learned it. It must mean it was a really good option. But I like the table. I think it's very helpful. Any questions about that one? So, big idea, the derivative of the inverse is a reciprocal. Try this one. Okay, so f of x and f inverse are both differentiable with f of 3 equals 5 and f prime of 3 equals 7. Find the tangent line to f inverse at 5. What are the 3 things I need for a tangent line? X, Y, slope. Hopefully I can figure that out in this problem. Now, the challenge to these problems, because I imagine you're thinking this isn't too terrible. The challenge to these problems is AP will not write that table for you. Yet I had never seen that table until I saw it as a teacher. So you'll have to know on an inverse function problem to draw the table. Sorry. So I know that on f of x, I'm looking at the 0.35. That's the information they give me. They give me information about the 0.35. They tell me the slope is 7. So that means at the 0.53, I know the slope of 1/7. That's good because that's the only way I can do this problem is if they ask me to find a tangent line at 5. It's the only place I know information about. So the tangent line is y minus 3 equals 1/7 times x minus 5. Any questions about that one? If g of x is the inverse of f of x, use the table of values below to find g prime of 2. Okay. So remember, g of x is the inverse of f of x. They aren't giving me a table. There's a table here, but it's not my table. So the first thing I'm going to do on this problem is set up a table. I've got f of x, and I have g of x, which is f inverse. I know that when x I want to find g prime of 2, right? That's my goal. So I want this to be a 2. Does everyone see how I know that information? So now I need to go back and fill in the table. Well, I know that 2 is an x value on g of x. What kind of value is it on f of x? Y value. Which means what's the corresponding x value? -3. How did you find that? Good, it's in the table. That -3 f of x is 2. Do you see how this could have been a really difficult problem without that table? Trying to piece that together. I will show you the other way as well. The m will be 5. So, what is g prime of 2? What's it? G prime of 2, the slope is 1/5. Now, if you were doing this the other way, you would have to do that, right? And you go, well, what's g of 2? And that's where you would say that's -3 because it's the inverse. And f prime of -3 would be 5, so this would be 1/5. So there's your 2 options. Table option, formula option. I saw a light bulb on the formula over here.
No, I thought it. Okay, so where are we getting the g of x?
Well, it says that g is the inverse.
Oh, so we just switched those.
Right.
And we're putting f of x as the first x. Oh, I get. Oh, okay. I see how the table's set up. Okay.
So all of this information, completely useless. Distractors. Right? Does everyone see that? What do you think the most common answer on AP test is on this problem? 4 or a 4th? That's the most common mistake people to make. They look here because of the 2, but since the 2 is a y value, since it's an inverse. Again, to me, the table makes so much more sense. Okay. So that's essentially the worksheet you got. That covers the worksheet. So we're going to see how much time do I have left. 4B 10:40. I already got 10 minutes. 10:40. Oh, that might be right. Hold on. 4th B lunch 10:40. System. Alright, so you've seen them on your calculus helper. The next thing I want to do is show you why sine inverse's derivative is what it is. Tomorrow the only goal will be to show you why the trig function derivatives aren't what they are. Not trig functions are the natural log, and to solve this inverse, if I didn't know the answer, now I know we have it on our calculus helper, but I imagine a few of you want to know why, right? I don't know a whole lot about sine inverse, but I know if y equals sine inverse of x, then sine of y would equal x. And just like I did with f of g of x earlier, I could do the implicit differentiation here. So what's the derivative of sine of y equals x? So dy dx equals 1 over cosine of y. In fact, there is a school of thought that would have you do that derivative that way. Is that what's on your calculus helper? No. So how do we get there? Well, I guess we'll finish this one tomorrow. Here is your homework is written on your sheet. But go ahead and write this one down too. I have a little more explaining to do, but it's more the why and how. The what is finding derivatives of logarithms. So 2 through 26 even, which is 13 problems. It's just finding derivatives of logarithms, which you've done on the gateway already. So both of those are due Friday. You have this book page is written down on the worksheet. You don't have to write it down. It's down there. Any questions about this? How did you feel about today? Derivatives of inverses? Good? A little shaky? Did you like the table better?